last video for chapter 8. The previous video talked about the first ionization energy. Ionization energy was the ability to take off an electron, so to remove an electron, forming cations. Electron affinity looks at the ability of an atom to accept an electron, so it's going to form an anion. So ionization energy, the energy required to rip off an electron. Electron affinity is the desire or the ability of an atom to add an electron. So if we look at chlorine, right, chlorine likes one electron to form the chloride ion. The energy associated with adding this electron is actually represented in our table here according to the delta H value. And this requires negative 349 kilojoules per mole. Excuse me. If you look down here, we notice this is a positive value, and this is because of the way that the electron affinity is defined. It's a little weird, but it's actually defining our atom's desire to add or accept an electron in kind of the reverse concept. So it's basically, what is the probability, what is the energy associated with doing this? Okay, what is that? And that is going to have the positive value, which is represented in our table here. And this table comes from your book. Our electron affinity is going to, again, roughly follow, again, the effective nuclear charge trend. And that is, the greater the effective nuclear charge, okay, the greater the positive charge in our nucleus, the more energetically favorable, the more desire that atom has to gain an electron or to add an electron. So as we move from left to right, okay, our electron affinity is going to increase. And also as we move from bottom to top, our effective electron affinity is also going to increase. The last section in your book goes through all of the representative elements. It's a really interesting read because it goes through each group, kind of talks about what chemistry can be done with each of the elements, what cool things they do, why they do what they do in terms of their electrons, their valence electrons. So it's an interesting read. You know, if you really can't fall asleep one night, whip out your chemistry book, read section 8.6. I will not specifically cover it. I won't ask any questions from it. It's there for your information if you so desire it.